Welcome back. In this module, we are diving deep into Domain 3, specifically focusing on the critical phase of information systems implementation. While development gets a lot of attention, the actual move to production, the go-live, is where rubber meets the road. We will explore how configuration management and release management act as the guardrails to ensure that systems are stable, secure, and functional when they reach the end user. Let's get started. Let's situate ourselves in the System Development Lifecycle, or SDLC. We are in Phase 5, Implementation. This is the moment we synthesize our buy versus build decisions into a live system. It is not just about turning a server on. It involves installing hardware, configuring the OS, and migrating data. Crucially, before we go live, we must achieve two things: certification and accreditation. Certification is the technical verification that the design works. Accreditation is management's formal acceptance of the system's risks and fitness for use. Without accreditation, you do not have permission to launch. This phase also includes the heavy lifting of training users and converting legacy data to the new format. This flowchart visualizes the implementation workflow. We move from development and testing on the left into the core implementation block. Inside, we have parallel activities: installation, training, and data conversion. Note how all these feed into certification, the technical check. Once certified, it moves to accreditation, the management sign-off. Only after accreditation do we reach the go-live state on the far right. Now let's talk about control. How do we stop a system from drifting into chaos? We use configuration management. This is the accounting of the IT world, maintaining detailed records of every hardware component, software version, and configuration setting. The heart of this concept is the baseline. A baseline is your stable, approved reference point. If a server crashes, the baseline tells you exactly how to rebuild it. It also involves strict version control. If a programmer changes one line of code, version control tracks it. Why is this vital for an auditor? Because if you can't track the configuration, you can't secure the system, and you certainly can't fix it efficiently if it breaks. Here we see the state of a configuration item. We start with baseline created. This is version 1.0. When a change is requested and subsequently approved, we don't just hack the system. We establish a new baseline version 1.1. The loop back shows the continuous cycle of versioning. However, note the rollback path. If the change fails, configuration management allows us to revert instantly to the previous safe baseline. While configuration management tracks the state of the system, release management governs the movement of changes. Think of release management as traffic control. It ensures that a software update, a release, moves safely from the developer's laptop to the testing server, and finally to the live production environment. We never, ever move code directly from development to production. We must pass through a staging or testing environment first. Best practices now rely heavily on automation tools that automatically deploy code to reduce human error. As an auditor, you want to verify that this process is documented and that there is a strict separation between the development environment and the production environment. This sequence diagram illustrates the flow of a release. Action starts on the left in development. They send a release package to the staging/test environment. Crucially, the code stays there for step 2, user acceptance testing and security scans. If it fails, it goes back to dev. Only if it passes does it move to step 4, deploy to production. This visualizes the mandatory air gap or gatekeeping role of the test environment. Implementation often requires moving data from an old system to a new one. This is data migration, often using the ETL model: extract, transform, and load. This is high risk. Imagine moving financial records. If you lose a decimal point during the transform phase, you corrupt the company's ledger. To manage this, we use specific changeover strategies. Parallel processing is the safest but most expensive. You run the old and new systems side by side and compare results. Phased changeover moves one department at a time. The riskiest is abrupt or big bang changeover, where you shut off the old and turn on the new instantly. Auditors look for validation reports, ensuring the record count in the new system matches the old system exactly. Here is the ETL data flow. We start at the top with legacy data. We extract it, then hit the diamond transform. This is where we clean the data. Notice the split. Bad data goes to an error log, crucial for audits, while valid data is loaded into the new system. The final step is the validation check, which loops back to compare against the legacy data, ensuring 100% integrity. We mentioned certification and accreditation earlier, but let's deep dive. Certification is a technical exercise. It involves penetration testing, code reviews, and verifying that the firewall rules are correct. It answers the question, does it work as designed? Accreditation is a governance exercise. It involves a senior executive, often called the designated approving authority, reviewing the certification results and signing a document accepting the risk. It answers the question, Are we willing to turn this on? As an auditor, if you find a system running in production without this formal accreditation, it is a significant compliance finding. This diagram separates the responsibilities. The technical team class on the left contains methods like perform testing. They interact with the system to change its status to certified. However, only the management class on the right has the method sign accreditation. They take the certified system and change its status to accredited. Only then can the system status move to live. This highlights the separation of duties. What happens when things go wrong? We need emergency changes. Maybe a server is down or a hacker is attacking. You might not have time for the full change control board meeting. However, emergency changes are not a free pass. They must be documented, and they must be reviewed and approved retroactively. A critical aspect here is patch management. When you apply a patch, a hotfix, there is a danger. The patch might overwrite your custom security settings, resetting them to insecure defaults. Therefore, an auditor must verify that security settings were rechecked immediately after any patch was applied. Never assume a patch is safe. This flowchart manages the emergency path. Starting with an incident, we ask, is it urgent? If yes, we branch to emergency fix. We apply the patch. Crucially, look at the next step. Verify security settings. You cannot skip this. Then we move to retroactive documentation. And finally, formal approval. The process isn't over when the fire is out. It's over when the paperwork is signed. We are ready to flip the switch. How do we do it? We have 3 main strategies. Parallel is the safest. You run both systems. If the new one breaks, the old one is still there. But it's expensive. You do double the work. Phased is a middle ground. You deploy to the London office first, then New York. Abrupt, or cutover, is the scariest. You turn off the old and turn on the new. If it fails, you are in trouble. That is why every abrupt changeover must have a tested rollback plan. If the new system fails, how fast can you revert? The final step before flipping the switch is the go-no-go meeting, where all stakeholders confirm readiness. This quadrant chart helps you visualize the trade-off. Look at the top left, abrupt cutover. It is low cost, left, but high risk, top. Now look at the bottom right, parallel processing. It is low risk, bottom, but high cost, right. Management must choose where they want to sit on this chart, based on their risk appetite and budget. The system is live. Are we done? No. We must conduct the post-implementation review, or PIR. This doesn't happen the day after launch. We wait weeks or months for the system to stabilize. The PIR asks the hard questions. Did we get the return on investment, ROI we promised? Are the users happy? Did the controls actually work? This is where we calculate the actual cost versus the budgeted cost. The output is a PIR report sent to the steering committee. This closes the loop on the SDLC and provides the lessons learned that make the next project better. This concludes our module on implementation. Our final journey map shows the emotional and functional path of closure. We start with go live high activity for IT, high stress for users. We move to stabilization, where adoption improves. Finally, we reach the PIR section. Here, management calculates ROI, the auditor gathers lessons learned, and the steering committee formally closes the project. High scores at the end indicate a successful governance process.